Hey, in our last target, we talked about reflections in mirrors. And in this target, we're going to talk about refraction in lenses. So today, we're going to learn a little bit about lenses. And our target is to be able to explain and predict refraction in lenses. So let's go ahead and let's talk about what refraction is and some of the different types of lenses. Let's draw some ray diagrams for lenses and let's do some stuff with lenses. Okay, lenses work a lot like mirrors, except instead of reflecting light, they bend light. As light moves through the glass in a lens, it gets bent. And we call that bending, we call it refraction. So mirrors reflect light and lenses refract light. Okay, and just like with a mirror, you can have two different kinds of lenses. You can have a convex lens, which bends outward, or you can have a concave lens, which curves inwards. So let's go ahead and let's take a look at a couple of these and let's draw some ray diagrams with lenses. When you draw a ray diagram for a lens, it's very similar to drawing a ray diagram for a mirror, except the light isn't reflected, it passes through. Okay, let's draw a ray diagram for a convex lens like we have here. Okay, so I have my convex lens and I'm going to draw the principal axis straight through the middle of it, just like I did with the mirror. Okay. Now with a mirror, you had a focus on one side or the other. For a lens, you have a focus on both sides. So we want to draw the focal point on both sides. So let's say, I don't know, maybe the problem tells you where the focus is. I'm just going to say it's right here, just for the purpose of example, right? And then I want it to be also on the same side, and it's the same distance away, right? So if it's this far, maybe it's right here. Same distance away. Now we need an object that we're looking at through the lens. So let's put a pencil maybe right about here. And again, just like with the mirrors, we're going to draw it so that the bottom sits right on the principal axis. And there's my object. Okay, now let me get a ruler and we're gonna draw some rays and we're gonna see what the image looks like. Okay, now to draw the ray diagram, you need to make two of the following three lines. Okay, there's three lines you can make. They should all intersect in the same place. Two of them will show you where that intersection takes place. Okay, the first one. Draw a line from the top of your object to the lens and then down through the focus. Top of your object through the lens and then down through the focus. Draw on the board and not on the ruler. There we go. Okay, the second will go down through the focus to the lens and then parallel to the axis. So down through the focus to the lens and then parallel to the axis. Not the best parallel, but I should have drawn this one further out. Let me draw this one a little bit further out. Okay. And we can see they're going to intersect right here. And the third line will be a line that goes from the top of the object straight through the middle of the lens. So something kind of like this. If I were a better artist, all three lines would hit up in the same place. But my third one's a little bit off here, right? That's okay. I have two lines that come together in the same place. And that place is the spot that corresponds to the top of my object. So what I'm going to do is I'm going to draw my object here. Since it's below the principal axis, I can see that my object is going to be upside down. Or I'm sorry, my image is going to be upside down. I can draw that better. Okay. You can see my image is upside down. It looks like it's larger than the object, and it looks like it's further away from the lens than the object was. Okay. It's called a real image, right? Real and virtual with lenses are kind of backwards from mirrors. With a mirror, a real image ends up on the same side of the mirror as the object. For a lens, if it's on the same side as the object, it's a virtual image. Ones that are on the opposite side are real images. These ones can be projected onto a screen. Let me show you. Okay, I am up by the window here, and I've got me some lenses and a paper. And I'm going to try to show you a real image formed by a lens. Okay, so across the street from me is a water tower. And I'm going to take this lens, and I'm going to place it right above the camera. And I'm going to move the paper towards it. And hopefully, you're going to be able to see the real image on the paper. And this lens isn't the best lens for doing this. I'll use a better one in a second. But maybe you can see projected onto the paper there the water tower across the street. It'd be upside down. If I use a different lens, here I'm going to use this lens now, the image will be smaller, but it should be brighter and maybe easier to see. Maybe I got to get too close. Oh, there it is. You can kind of see it there. Maybe it'd be easier to hold it like this. Then my hand's in the way and you can't see it. The lens is in the way and you can't see it. You can see there the real image formed by the lens. We're projecting that image of the water tower across the street. You can see it right side up through the lens. Okay. Let's draw one for a concave lens. Okay. Let's draw our principal axis. Put a focus on either side. Let's say maybe the focus is right about here. Same distance on either side. Okay. And then let's draw our object. Let's say our object is maybe out here, outside of the focus. If we were to draw it inside of the focus, we might end up with a very different picture. So let's choose to look at the one outside of the focus here. Okay, there's my pencil there. So what we're going to do is we're going to draw our first line with the the concave lens. What's different is I'm going to draw my first parallel line. And then instead of going through the far focus like I would with a convex lens, what I'm going to do is I'm going to back it through the near focus. So I'm going to line it up like this. I'm going to draw dashed on this side, and I'm going to draw a solid on this line, on this side. So here, the light, so with your concave lens, the light refracts away from that focus on that side. Okay, my second line will go straight through the middle. Okay. And my third line well, I don't need a third line here because I can see where the two intersect. They intersect right here. Okay, so that right there would be the top of my image. So the pencil will appear like this. Looks tiny there now, right? The image is tiny. So you can see the image is closer to the lens. It's much smaller. It's right side up still. And it is on the same side of the lens as the object is. Interesting situation happens when you have a convex lens, and your object is right at the focal point. Okay, so watch this as I move this closer to my face. What happens? Look at that. Where's the image? Where'd the image go? If I bring it even closer, now I'm upside down. You see that? Now I'm upside down. Now I'm going to bring it closer, or further from the object, which is me. I'm the object. And look at that. I'm upside down. Where's the image? Where'd it go? And now I'm right side up. It's kind of freaky, isn't it? So, right about here, this is the interesting situation, right? Where's the image? Where'd the image go? Let's draw a lens diagram for that. Okay, so this is a convex mirror lens, I'm sorry. And let's draw our principal axis. And let's make up some focal points here. Let's see, here is a focal point, and it's about the same distance on the other side. Not about the same distance, it's exactly the same distance. Okay, let's draw an object exactly on the focal point. So here's an object exactly on the focal point. Okay, so our first ray will go straight to the lens, parallel to the axis, and then come down through the focal point. Our second ray can go straight through the middle. You can probably already see what's going on. Okay, you see my two rays here? We're looking for the place where they intersect, but look at them. They don't intersect. They're parallel. And this is the situation you get where the image disappears. The two rays don't converge. Pretty neat, huh? So there's a little bit about refraction in lenses. Hopefully that helps us to be able to explain and predict refraction in lenses. Yeah, until next time, take it easy.